Welcome to Ask and Learn.
So the domain for this one is x is all real. The intercepts, if we set our x values to 0, we see that y is 2, so we have one intercept at 0, 2. Symmetry, there is no symmetry, it's not odd or even. Asymptotes, so we do have a slant asymptote, and if we look at the limit as x approaches infinity of our function, which is 1 plus 1 over 2x plus e to the power of negative x, we see that we get the limit of 1 is 1. The limit as x approaches infinity of half x is infinity, so plus infinity. And our last term, e to the negative x, we plug in the infinity, we get 0. And we get infinity. So that's saying that there are no horizontal asymptotes, but we do see a slant asymptote where our limit does not go to 0, so that's anywhere that's not going to 0, so we see 1 and infinity. That corresponds to the 1 and half x, so therefore y equals 1 half x plus 1, or you could have said 1 plus 1 half x, is our slant asymptote. Alright. Next thing we can do is find f prime. So our first derivative is 1 half minus e to the negative x, and solve for our critical points, and we have x equals ln of 2. Alright, and if we do the first derivative test, so this is f prime, and we look at ln of 2, and by the way, ln of 2 is approximately 0.7, that's just to help us graph, and f of ln of 2, so into our original function, if we plug in that critical point, we're going to get approximately 1.8, just so we know where to plot this. 1.8. Alright, so if we look at anything below ln of 2, it's going to be decreasing, and anything above, it's going to be increasing. Okay, so that's the first derivative test. And now if we want to use the second derivative test to help us, we see so the second derivative is y double prime. That's going to equal e to the negative x. And we know that always has to be greater than 0. It has to be positive. So it's going to be concave up on our whole domain, concave up. So that's the second derivative test. Okay, and now with this information, we can graph. Right, so we know we have an intercept at 0, 2. So let's say this is 1, this is going to be 2. And we have our, since this is decreasing and then increasing, it's going to be a local minimum value at 0.7, 1.8. So let's say this is 1, so 0.7 and 1.8, somewhere right here, we're going to have a local minimum value. And we have an asymptote at y equals 1 half x plus 1. So one half x. So it's going to go up 1 over 2. So this is just a rough sketch of the asymptote. So that's our slant asymptote, and our graph is going to be concave. It's going to be decreasing, then increasing, but it's always going to be concave up. So it's going to look something like this.